The biggest challenge in data analytics is that projects are failing. Gartner estimates that 50 to 80% of all data analytics projects fail. Despite having great new people who are data scientists, great new tools and databases, $150 billion in spent every year in tech, it fundamentally comes down to a people and process problem. And that's what DataOps tries to address. It focuses purely on helping people in their process, with their tools, with all their data, be successful and deliver unparalleled insight to their customers.
Good afternoon. Welcome to Track 5, Leadership in Action, learning about different success stories, lessons learned. I'm Bob Audette, partner data management at Guidehouse. And today's session is going to be mission control for data operations. And it's really a must-have. And some of the session is going to cover off on a couple key questions. One is, why is the lack of enterprise-wide why does the lack of enterprise-wide view of the multitude of data analytics pipelines in production cause repeated failures and missed deadlines? Why reducing production errors and monitoring data teams development dramatically improves team production? And many other types of questions related to this topic. I do want to cover on a couple logistical things. The session is being recorded and the contents will be available in the Wahoo app. Secondly, you'll be able to access this session 3 months from now, and it'll be out on the MIT CDOIQ YouTube site. The other thing is regarding questions. For those in the room, please, if you do have a question, kindly raise your hand. I'll give you the mic, and then please pose your question. Otherwise, those that are virtually can hear your question. Those that are virtual, please use the Wahoo app to actually pose your questions. And for those in the room, feel free to use that as well. And with that said, I'd like to introduce Chris, CEO of DataKitchen. Chris has a really distinguished more than 30 years of research, software engineering, data analytics, executive management experience. He's held multiple executive titles, COO, CTO, VP, Director of Engineering. He has a Master's in Science of Columbia University, a BS from the University of Wisconsin-Madison. He's recognized expert on DataOps, published numerous books on the topic, the DataOps Cookbook. Chris really began his career at MIT's Lincoln Laboratory and NASA Ames Research Center. So now I'll pass it off to Chris for his session.
Yeah, thank you so much. So it was interesting looking at the application today, the MIT application. They had a survey of like, what's your biggest problem in data and analytics? And the number one thing was data quality. Or, and I think what it said is people don't trust the data. And so in some ways that's a risk. Like, why don't people trust the data? There we go. And so I guess from my perspective, I've spent about 15 years working in research and software development, and then I joined the data world about 2005, and it was hard. Like, I had a whole bunch of people working for me who did data science and engineering, and things were breaking left and right, and I had this thing called the morning dread. I don't know if any of you have it. I went into work and I just didn't like what I would see. Sometimes I would hide in my car, sort of bracing for the day. Oh, is something going to go wrong? Is the dashboard going to be late? Did somebody screw us over with bad data? And so it was difficult. And as an example, just recently talked to a company. He had a data report go wrong, and the CEO of the Fortune 15 company called him up to yell at him. He's the head of a data team. He had to get 26 people for 6 hours to find out where it is. And that just seems too much risk to me. You don't want to dread going into work. You don't want to have all your smart people in your team diagnosing what a problem is. And so what it really means and what our company is about is trying to address these challenges, because it's too hard and it's too frustrating to build insight. And as we go, it's my 5th or 6th year presenting here, and a lot of data and analytic projects don't work, they fail. In fact, what's interesting is we did a survey last year with Data.World, who Juan is speaking in the next meeting, and that 78% of data engineers are so stressed they want their job to come with a therapist. So why is that? Like, are they mentally ill, or does the job just kind of suck? And so I think the idea here is that we have a very complicated world that we run in. Complicated data, complicated tools. Just in the last 5 years, the move to the cloud has brought in a whole level of new tools and technologies. And so the assembly line that we use to build data and analytics solutions, from data engineering to data science to data visualization, is complicated. And sort of if you walk the journey that data takes from its source to its value in a report or a model, it's complicated, right? And it's not just one tool, one place. It goes through many places, and it's almost like manufacturing insight. And if you're in charge of a data team, a lot of people that we've talked to and a lot of our customers before they worked with us couldn't answer these basic questions, like, did the data arrive on time? You know, are my new reports or my new models done on time? Should you trust the data? Did I check it before you saw it? How many jobs ran yesterday versus today? Are they late? What's coming today? And is the model that I have in production still accurate? Or is the dashboard still working? And it seems to me that there's sort of basic production level analytics that we're not doing very well as data and analytic leaders. And so some ways the theme of this talk is that you should get analytic about your analytic systems. And a way to do that is to think of it as risk. And so how does NASA manage risk? Well, they put everyone in the room. They gathered all the information about takeoff and status of various things and put it on a bunch of screens. And then they kept it in one place over time, so when something goes wrong, they could analyze it. And so this idea of mission control is what I'm going to talk about today. And the real point of it is to alleviate the hassle and the pain that you feel in building and delivering analytic systems. And how we arrived here is that we've been talking about something called DataOps, data operations, for years, which is really the application of sort of Agile and DevOps and TQM techniques to data and analytics. And so we think the first step is really to get the problems, to get the errors under control, and to really build a sort of mission control system. And so the next part of this is really to talk about kind of what the characteristics are of the problem and why it's worth solving. And so I'm going to talk about this as DMC, or DataOps Mission Control. And so one perspective is that this manufacturing perspective on data and analytics, and whether the data is big or small, or whether it comes in batch or in streaming or whatever, you have a tool chain that you manufacture insight. And it goes into a database, it goes through a data transformation tool, it goes into a model and visualization. And just like a car is assembled from its components, a dashboard or a model is assembled from its subcomponents. And so you've got lots of tools acting on your data. And so, but different than a Toyota factory, where maybe you have one of these assembly lines, you have dozens, if not hundreds, of these assembly lines running simultaneously in your organization. And there's the bigger the company you are, the more of these, I'm going to use the term pipelines to talk about this, but it's really, think of it as the journey from raw data all the way out to customer value. They're everywhere. And so, we talked that company that had the issue with 26 people, they have 2,000 production pipelines. And no idea sort of where they are. Because, why is that? It's hard, because the operations in your data and analytic team, these pipelines, are a reflection of your organizational structure. They live in different places. Some of them are central, some of them are hub and spoke, some of them are aligned by function, some of them are aligned by division. And so the other aspect that's interesting of these data and analytics systems is that they're not static. So when you manufacture a car, maybe you change the car assembly line once a month, or maybe if you're Tesla, you do it once a week. But our data and analytic production systems can, because they're software, they can change quite quickly. So you have a process to put things into production from development, to get things from your data engineer and data scientist head into that insight system. And unfortunately, it takes a long time for a lot of organizations. It could be weeks or months before something happens, before that 20 lines of SQL, that new model is actually taken from the desktop or the development environment and put into production. And also the process of putting things from development into production is not consistent around companies. So they may have multiple environments, a dev, a QA, a UAT. Some of them may just push a button. They may be a self-service team and they press a button in Tableau that deploys to production. They don't have any process. And so the standards in how you get things into production vary. And so one of the ideas of mission control is that you should be able to understand what's happening. You've got all these production lines. You've got all running in production. You've got a process of getting things into production. And so one of the ways is like take that information about that and put it in one spot. And because you've put it in one spot, the constituencies in operations, the people who run operations, the people who build the factory, the people who manage people who build the factory, even business people who are using the information are used to it. And that sort of single view of your operations is what we're about. Because, you know, if you're a data engineer, do you really want to answer questions from your customers about, is it ready? No, you want to be able to do good work. If you're a manager, you want to be able to answer questions of how is productive as is my team? And when someone says a problem in the data, and you can say, no, we ran 4,000 tests on that data. And if you're a person who's using a production person who's in charge of running these thousands of pipelines, you want to know if something's wrong. So this sort of shared context between these constituents in our organization is something that's lacking. And why is that? So why is this, if we have an assembly line, things are breaking, we have customers who are demanding lots of new things, but it takes a while to get in, why haven't this been solved already? Well, there's a set of technology that IT organizations have called application performance management, and there are tools like Datadog or Splunk, and they accept things from the server level. Sort of things like the CPU, the disk space, process errors, and they have logs and traces that they go. And it's great, right? Because that's really good information. However, it misses the point. It's sort of looking at the floor when you really should be looking at the assembly line. And our systems are built on top of this information. And so they don't actually check that the data is right, or that the dashboard is still showing the right information. They're good for diagnostics, but not good for getting actual information. And so for us, we actually think that you need to build something above what you do. And for the purpose of this presentation, I'm calling it an observational pipeline. And so it doesn't run things, it just observes what goes on. And in this picture below, you see all those tools. Right? So imagine a really simple case. I get data, it goes in an S3 bucket, goes into Snowflake. I use Talon to do data transformation. I've got a Python model, and then I use Click to view the data. So you got 4 or 5 tools, a couple of different locations. Did it all work? Did it all get through? When I get a call, what point did it break? And so being able to look at the world. And so if you look at this case of a process to get value from data, and take a really simple case where data comes in, maybe you have 10 files that come in, it gets into some buckets, it gets into a database, and gets into a Tableau report. Then you have a bunch of tools. Maybe you're a fan of the modern data stack and you're using Fivetran and DBT, maybe you've got some Jupyter notebooks and some Tableau. So now you've got dozens of data sets, you've got dozens for tools, and then you have some ways to run those tools, like Apache Airflow, which orchestrates or schedules. Maybe you have a cron job. And so now things are starting to not go well. How do you know where it is? Is it the data? Is it the transformed data? Did Tableau fall over? Did someone put in a report into Tableau that had a calculated field that was wrong? Where is it? Is the server getting too bad? And so this idea of an observational pipeline encapsulates that idea, abstracts it. And also it's useful because it's a shared context for the organization to understand what's going on with their data operations. And what's interesting is that these ways to view the world, this observational pipeline, is an abstraction of the complexities of production. And so there's a lot of levels to do this. Did something go wrong in the report? A node in the airflow graph? Did it go wrong in the data? Is the server pinned? And so we want to, the idea here is, can you abstract that up? Can you chunk it into reasonable bits of information to get good understanding by people? And then second, can you actually represent the tribal knowledge of operations? And I don't know how many of you have put things into production where it requires a button push or something scheduled and then something else scheduled. One's at 3 a.m., one's at 5 a.m., and if they sort of run completely independently of each other. And suddenly your customer's saying, this is wrong. And you're like, I don't know, is the data wrong? Did something not run in order? And also there's relationships between organizations. So we talk to a lot of big companies. Central IT is having a lot more sort of hub and spoke model, where it's a data enablement organization, and then you have self-service data. So you bring in a data set, and it has relationships to other data sets that it could impact. And then there's the idea of a data mesh, right? The idea of domain-driven design and having, so you get an operationally complex environment with interrelationships between each piece. And so that tribal knowledge isn't anywhere, or maybe it's in a document, or maybe it's in one operations head. And so you start having the death of 1,000 knives without this. And the idea is that you should build an expectation of the way the world should be. This should run at this time, followed by something else. It should be you should test the data to see if it's right, and you should be able to tell if it's late, and be able to judge the expectations of the world versus the reality of the world. And then get data about it, and be able, get data about it to be able to see what's going on, and build sort of events and alerts on top of it. And so the idea here is that once you build a data and analytics system, don't trust that it's right. And I talk to a lot of people, they build something and they sort of hope the data works. Oh, I've delivered it. I checked it in UAT. I have no idea, is the data good? Did it change suddenly? And so you need this idea of automated data checks or data quality checks. And so it's not that I don't trust the people who provide data, it's that I don't trust them at all. I've been sort of screwed over so many times by data providers who forget that you exist with all good intentions, and how do you know? And it's not like that's going to change. So you need to sort of protect yourself and think about testing in two different ways. Think about testing the data and the things that are happening to data during production. And then think about the opposite of that, checking from the code that is acting upon data in development. And I think those are both actually related. And so, because what most organizations want is to have a lights out operation. Data's coming in, insights going out. I can focus my time on creating new value instead of tending and fixing errors in the past. And a way to judge that, and my belief is that you should work in an agile manner, deliver small bits of insight quickly. And if you do that, small bits of insight quickly, where you've automated the world around it, you've built an observation system on top of it, then you get more time to deliver value, you can find what customers really want, and your productivity goes up and your customer success goes up. So that's, if anything, I've been talking about this idea that there's an operational world that you live in, that it's worthwhile to invest in, to fix in, to automate. This idea of automation, testing, observability, it went like a storm through the software world in the last 10 or 15 years. The average software development team has 28% of their staff devoted to what's called DevOps, which is observability, testing, deployment automation. And I think we should do the same. And I think we should start with this idea of observability. Because in a lot of cases, this idea of testing is not unique. All of us have check data, row count checks, simple checks, and so there's just many sources of checks. And so from that standpoint, is just to do a quick summary. We do have a product that helps this. It's called that we're in development right now to sort of build that central view of cross data operations and be able to see every pipeline and every organization and drill down into its status and then build this idea of the observability pipeline. That's a representation of the complexities of your world. And we've got some other software. I don't want to go into that, but that's it for my discussion today. And so how much time do I have? Oh, good. I'm getting quite 8 more minutes.
Any questions from the audience?
So how many of you have had problems with production falling down and had to grab a whole bunch of people? And so how did you fix it? How did you go about addressing that challenge?
Sorry, could you please?
So if you've had a production analytics system fall over, how did you go about finding it, and then how did you go about addressing it?
So actually, I work for Fidelity Investments, and I manage advanced data analytics technology team. And we have data quality is a big, it keeps up at night actually, So once we identify, actually, we have a dashboard. We use the timeliness, completeness, accuracy, and we run the Python programs nightly on the transaction system to make sure that historically verify, the data and run analytics. Now it fails, now we identify that, we have to dig deep into where it failed, the lineage and across the data, where it failed. That's a manual work for now for us. So that's to answer your question, but I have a question as well. Have you seen a successful organization where they have data quality and how they are set up actually, so
Yeah, I think I've seen more unsuccessful organizations with data quality because there's two aspects, I think, to the term data quality. One is the sort of passive measurement of, think of it as the balance sheet in financial terms of your data. Is it good? Is it bad? The sort of DAMA dimensions of data quality. I think that's wonderful stuff, just like a balance sheet is a wonderful way to judge your company. But I run a company, I'm actually more interested in the cash flow of my company, right? Are we going to have enough money a year from now to stay in business and enough money next month to pay employees? And so we do, by the way, so don't worry about that. But I think of that as a more active, more time-based way. That's an active measurement of where you are day in and day out. And I think that's something that is lacking. And I do see organizations making changes on that, implementing observability, implementing automated data tests, just like you. When the data lands every night, you want to know if it's still good, right? And you don't want to once a year do the balance sheet of your data. It has to tell you, because you have to identify if the data is wrong, or if the report is wrong, or if someone did a transformation of the data is wrong, because your customer, in my experience, your customer does not care. You are magicians, right? And the magicians stopped giving magic correctly, and I am mad, and I'm going to go stomp my feet until it's right. And you can either put your head in the sand and ignore that, or you can try to do something about it, and do something about it in a way that drives scalability and drives automation, so you don't have to worry about it again. And so I think the best answer to these challenges of production problems is to say to your customer, yep, you were right, yep, we were wrong, and we're going to put a check, or we're going to put some automation, we're going to put that into our observability system and say it'll never happen again. And I don't know, I found that to be a much more effective way, because data is combinatorially complicated, and so you can't check everything. I don't know, Anthony, were you going to bring something up? Oh.
Thank you. Yeah, I have a question around testing. I saw on one of the slides you had performance testing and all the good stuff. How do you manage or enable that without particularly for using production data or production-like data, right? How do you do that? Do you rely on IT providing a copy that's obfuscated, or do you do that yourself? And can you explain that?
Yeah, I think, so the question is, in development, you're going to check data for performance. You're going to check your analytic system to see if it's still working. And let me back up and tell a story as a preface to that. So I have a 22-year-old son who just got a job as a software developer. I'm very proud of him at Amazon. His room was a disaster growing up, sort of covered in Legos. When he was a teenager, it was just scary. Like, it's scary. He's an engineer. And so he took his job at Amazon, and he put code into production in Amazon's back-end system within 2 weeks. Now, it wasn't a lot of code. It was like 5 lines of code, but he did it. And so why does Amazon trust my 22-year-old son with in my mind, is still 8 with a room covered in Legos? Like, why is that? Well, because they built a system around him to be able to tell if my son made 5 lines of code, what's the impact of that change on everything else? And so I think what is the characteristic of those kind of systems in data and analytics? The first one is you need good, solid test data that is like production data, but is not. Some organizations right now we can throw 100 terabyte databases around, zero-copy clones in Snowflake, very easy. Some organizations have rules, privacy rules, limitations, and you need a privacy-aware data. In some companies, you're dealing with a 4 petabyte database. Maybe you don't want to copy and paste it, right? But the idea is, can you take a copy of your data and analytics system, run it against that, and have it tell the 22-year-old in the organization that this change worked? And this change in the database table affected the reports or the models, because the impact of an individual's change on a great system is what we're not building. And I think we should benchmark the success of all our teams to be able to have messy room 22-year-olds make a change within a month of their first job, and know that it's going to work, not hope that it's going to work. And if you can do that, then it's much easier to make changes. It's much easier to notice if the changes have caused problems. So it's a long-winded answer to a simple question around having good test data is important. And using that test data to validate the impact of your change, whether you're 22 or 62, you should be able to do it. And there's too many of us smart people who have to bless changes. You know, the bottleneck person who has the whole system in their head, they're a problem. Because every organization has a man or a woman who's like the smart person. And like, if you're going to make a major change, talk to Karen. She's got it all. She'll tell you if it works. You don't want to have that, because those persons, honestly, they get bored and they leave. And it's your best people don't want to be answering questions. They want to be creating.
The last question.
So I'm curious, because I love the idea of the mission control concept, but the thing in my head is like, how do you get the situational awareness from some of the systems and applications that aren't necessarily well set up to share that and are kind of reluctant to give you the keys to understand everything that's going on? They think it's some sort of competitive advantage to keep the information from you.
Yeah, I think there's 2 levels of information. You could argue that the information is a class of metadata. Right? It's operational metadata. Is it running? Has it stopped? Is the data good? It's not actually the core jewels, because you don't need to pass all your data into the system to make it work. And so I think that's part of it, is that the instrumentation of the core systems is important. And then the other part is the value of it. Proving to the people that if you instrument your system, you build these tests, you will have more time to do good things. Your customers will be off your back, and you can iterate quicker. And so I think it's the trade-off in any organization, because what we're asking people to do is to focus on the system next to the work they're doing. And if they focus on that, they're going to get better value. And that's that sort of 28% of all people in software development teams now are in DevOps. And they're actually more expensive than your average software engineer. And so there's a career path here that I think for people in this sort of data ops or operations side.
Can I ask a correlation to that?
Sure.
So in some respects, what you're talking about is a political question, not a technical question, right? So is there a model that you've seen that would allow there to be central and decentralized views of these things so that we can see, centrally there's lineage, but then you can also kind of deploy a local version where the local people could derive value from that?
Yeah, I think that's, I think you have to do that, right? The hub and spoke model, the sort of centralization versus freedom, states versus federal government rights, that's a characteristic that happens in a lot of organizations. And the value chain that delivers analytics in a lot of big companies is no longer centralized. Companies like Qlik, self-service tools, self-service BI, self-service data science, self-service data engineering, as well as the central IT function, have to work together. And I think one of the indications that things aren't going well is the Hatfields and McCoy. I put the data right, you got it wrong. No, your data's wrong, I got it right. And how do you resolve that? Well, I think having a central view so people can look at the same picture, not of the 360 degree view of your data, I'm saying the 360 degree view of your operations, so they can actually see the journey. If you can't see it, you don't believe it. And how many organizations have you run into where the central IT, the data providers are stuck because they don't know how many reports, what's used, they change a schema, they alter a data set, and hell breaks loose? It's never happened? Okay. 0 minutes, okay. So I think we're done. Thank you so much for the questions, very good questions, and I appreciate the time.
Thank you.